Okay, so let's look at the inequalities concepts, right? Let's start with the basics over here. Let's say we have something like 5x minus 3 is greater than 6, right? So how do we find what are the values which x can take, right? So we can always move 3 to the minus 3 to the other side. It's going to become a plus 3. So it becomes a 9. 5x is greater than 9. Inequality remains the same. X is going to be greater than 9 by 5, right? So we could be given a range that x has to be an integer less than 100 or 50 and how many values satisfy and so on and so forth. Now, coming to this concept, right? So where is the inequality sign going to be changed? So far, what we saw over here, there was no change to the inequality sign. Addition or subtraction, if you're moving it, it's perfectly fine, all right? The change happens when this division kind of thing happens over here. 5 when moved to the other side, it was a positive number, so nothing changed, right? However, if this would have been negative, things are going to significantly change. For instance, if minus 3x is going to be greater than 6, then x over here, if minus 3 is to be brought to the other side as 6 by minus 3, right? As the minus something negative is moving to the other side, it's going to be flipped this way, right? So that's it. X is going to be less than 6 by minus 3, which is x is less than minus 2, right? So that becomes the answer. Once again, if x is going to be greater than y, for instance, if you're going to multiply both sides with a minus sign, right, then the inequality is going to change this way, right? So take, for instance, 5 is greater than 3. But if you look at it as a minus 5 and minus 3, it's going to be less than, right? It's the other way around. And that's the underlying concept, right? So this negative symbol, the minus over here, you take it to the other side, it's the same as multiplying both sides with a minus 1, right? So that's what is happening. So therefore, the inequality gets changed. Moving to the next concept over here, again, onto the basics, right? The basics over here. Arithmetic operations not allowed, right, using variables, right? So what are the arithmetic operations with inequalities which are not allowed, right? For instance, let us say we have 5x square is less than x, right? 5x square is less than x. Now, I cannot cancel an x on both sides and say 5x is less than 1, right? I can't divide it over here. And again, I can't say x is less than 1 by 5. This is wrong and wrong. Why? Because of the previous concept, which is if I'm going to be bringing the x to the other side, right, to simplify, divide, I don't know whether the inequality sign has to be changed or not, because I don't know if x is going to be positive or negative, right? X, is it positive or negative? We don't know. If we know that it's definitely 1 for sure, then we can change the sign and accordingly move, right? Given that we don't know it, or we can't really perform this operation over here. So what can be done? So if we have something like 5x square is less than x, then I can have 5x square minus x is less than 0. And then I can take an x common over here. And I get a 5x minus 1 is less than 0. And that's it. We can draw this in the number line, right? And we've seen how x over here, the first term over here, becomes 0 over here. And if 5x minus 1 is going to become 0, then x is going to be 1 by 5, right? Those are the roots over here. We've seen that in quadratic equations, right? So find the roots, the points where they become 0. And the rightmost end is going to be a plus followed by a minus and then a plus, right? When can you do this? You can do this if the coefficients of x is going to be positive, right? So remember that the coefficient of x has to be positive. If this would have been a 1 minus 5x, you'll have to multiply with a minus 1 and change the inequality, right? So that's the underlying concept over here. Let's move to the next one over here. The next is more of linear inequalities, right? So linear inequalities, we can be given like simple, inequalities with one variable or two variables, but the power is going to be 1, right? Do these questions turn up often? Yeah, they do, right? So it's so let's look at a few of them. First one is from a relatively easy paper, but it was one of the tougher questions which turned up, right, in this particular paper. The number of solutions x, y, z to the equation x minus y minus z equals 25, okay, where x, y, and z are positive integers, such that x has to be greater than equal, less than equal to 40, y is less than equal to 12, and z is less than equal to 12 is what? Now wait, what do I know? All three are going to be positive. That's the first step. Now x minus y minus z and y and z are similar, right? In the sense the inequality part of it less than equal to 12. So let me rewrite it as x minus of y plus z equals 25, right? It's good. Now, I need to find all possible solutions of x comma y comma z, right? And these numbers are quite big as well. So x over here, what is the largest possible value it can take? It can take 40. If x is going to be 40, then y plus z over here, I know for sure has to be 15 for this to hold good, right? So if y plus z is 15, what are the possible values over here? When does it become 15, right? So y and z, if both have to be positive integers, right, it can start from 1 comma 14, right, and then a 2 comma 13, and goes on till 13 comma 2, and then a 14 comma 1, right? That's for y comma z. Okay, but what is not allowed over here? What is not allowed over here? Actually, 14 and 13 are not allowed because y and z has to be less than equal to 12, right? But what I would say is to see if there's a pattern which emerges and then look to restrict it, right? So let's go to the next one. If it's going to be 39, x is the next possible value lower than 40, that's 39. Then this has to be 14. And what do we have here? 1 comma 13, 2 comma 12, right? 2 plus 12 is 14, and so on. And we get a 12 comma 2 and a 13 comma 1 over here. Okay, right? And this process is going to continue over here. And if it's 38, it's going to be 38 minus 13. And if it's 13, I'm going to start with 1 comma 12, right? And 2 comma 11, and this continues. Let's come to the last one. It's going to be 12 comma 1, right? This is perfect over here because um, it's the max over here can be 12, right? Anything lower than this, if we come to 12, right, 37 minus 12, what's going to arise over here? It's going to start from 1 comma 11, right? One of them has to be at least 1, the other can be max of 11, and 11, 12 and all are perfectly fine, right? So this can go up to 11 comma 1. Now, here we can conclude as to what it's going to be. Now, how many possible values are over here, right? So 1 comma 11 to 11 comma 1, right? So we have 11 possible values over here. So let me write it down over here. It's 11 possible values. If it's 1 to 12, that's 12 possible values. If it's 1 to 13, let's write it down. I know 13 is not allowed. We'll come to it in the end. And 1 to 14 over here, 14 possible values. And this continues over here all the way till it should stop at 1, right? Where would it stop at 1? 27 minus 2, right? The only possible way is going to be 1 comma 1, and that's it, right? Y and Z have to be 1 and nothing else. So 1 to 14, if you're going to add it up, right? Some of the first 14 natural numbers, that's going to be 14 into 15 by 2, right? N to n plus 1 by 2, and you're getting 105. But some of them are not allowed, right? What are they? In the first one, 14, 13, 13, and 14 are not allowed. The rest are going to be 3, 12, and so on. That's perfectly fine. Right? 12 is allowed over here. And in the next one, 1, 13, 13, 1 are not allowed. The rest are fine. Right? So there's nothing else which needs to be removed. So 105 minus 6 and 99 over here becomes the answer. Right? So the answer is option 2. Option 405 is also present. Right? So you got to be careful with these. Right? So careful with these. Let's move to the next question now. Question 2, right? Same here, right? The paper was quite easy. And yeah, you did have some easy questions like this as well to pick, right? Compared to the previous one. Now, what do we have here? Let A, B, C, and D are integers such that A plus B plus C plus D is 30. Then the minimum possible value of A minus B whole square plus A minus C whole square plus A minus D whole square. A is being the difference of A and B, the whole square, difference of A and C whole square, and A and D whole square. And I have to find the minimum possible value. First up, they're all going to be positive because they're all being squared. You need to make that observation. Now, when will the differences be as small as possible? When they are as close as possible to each other. What is the other constraint I have? They're all going to be integers. Now, what are the closest integers I can find? 30 is a sum of 4 numbers. So 30 by 4, what's the average? 7.5. So let's put some of them as 7s and some of them as 8s. That's it. 7, 7, 8, 8 will add up to 30. They're the closest you can have. So A minus B whole square is 0 square plus A minus C whole square is minus 1 the whole square and then a minus 1 the whole square, and that's coming to 2. Can this be lower in any way? Let us say we make this an 8 and this a 7. What's going to change? 1 square plus 1 square plus 0 square. Once again, we get 2 only. So 2 over here is definitely the answer for this question, right? So quite a simple one compared to the previous question we did, right? Again, any paper, you're going to have easy questions and tough questions. We've got to be picking the easy ones, right? Moving to another one, right, pertaining to two variables over here, m and n, and we have an inequality, a slightly different kind of inequality, right? We have 0.2 less than a bunch of it less than 0.5, okay? And what else? M and n are natural numbers, which means positive integers. And don't do a speed reading to quickly rush into this and find this. Read every bit of it, right? So every word matters in quant. N is even as well, right? N is an even integer. M, we don't know, can be anything, right? We need to find the value of m minus 2n. There is only a unique value possible for m, right? Otherwise, I mean, how can we answer this? There's no cannot be determined here. So start with, n is even. That's the variable for which we have the most information, right? So which is the one with only n over here? N by 11, right? So if 0.2 is less than n by 11 is less than 0.5, and now 11 is a positive number, so I can multiply all of them with 11 and inequality doesn't change, right? So 11 into this is 2.2 is less than n is less than 5.5, greater than 2.2, right? What are the values allowed? 3, 4, or 5, right? Those are the integer values allowed, but n has to be even. So 3 and 5 it can't be. N has to be 4, right? N has to be 4, and we found the value of n, which is 4 over here. Now, given that we have n with us, we need to find the value of m over here. Let's start with m by 20 first, right? Perform the same operation. If we're going to be multiplying all of them with 20, m by 20 into 20 is m. 0.2 into 20 is going to give us 2 into 2, 4. And here we're going to get a 10, right? M is going to be between 4 and 10. And what are the possible values? 5, 6, 7, 8, and 9, right? Because it has to be a natural number, positive integer. Now, what is the only thing we're left with? N by m. But I know the n's value, which is 4. So I can say that 4 by m is going to be between 0.2 and 0.5, right? Only one value is possible. It's difficult for it to be somewhere in between. Take the two extremes and see which one satisfies. Take a 4 by 5. It's 4 by 5 is 0.8. Definitely no. What about a 4 by 9 over here, right? A 4 by 9 is nothing but 0.444. And that's definitely between 0.2 and 0.5. If you take a 4 by 8, it's going to be 0.5. It's equal to this. That's not allowed, right? So 4 by 9 is the only thing which satisfies over here. So m over here has to be none of these but 9, right? So m is 9, n is 4. So what is m minus 2n? That's nothing but 9 minus 2 into 4, 8, which comes to 1. Option 1 over here becomes the answer, right? So let's move to the next question. The next question over here, right? The number of distinct pairs of integers m comma n satisfying modulus of 1 plus mn is less than modulus of m plus n is less than 5, right? This looks like a complicated question, right? In reality, it is. But the things which should comfort us over here is that, they're all less. I mean, we have a modulus, it's going to open out to be 0 or positive, and it's less than 5. And we know that they're all integers, but given that they're integers, they can be negative as well, right? That should strike us. What is the smallest I would want to put for one of the variables, right? I could go in for a 0, right? If m is going to be 0, then what can n be? Try out an n is 1. Then what do we get? 0 plus 1 over here. No. First off, a 0 plus 0 is definitely not going to be true. A 0 plus 1 over here is not satisfying, right? 1 is not less than 1. So try out a 2, right? N, whatever value you put, right? It doesn't matter over here because it's 0 into that, right? So it's going to be 0. So 0 plus 2 over here, 2 is going to be greater than 1 and 2 is less than 5. Yes. 0 and 3, 0 and 4. Yeah. So all of these satisfy. What about minus? It can also be minus, right? And yeah. And this is where m is 0 and n are these values. What about the other way around, right? 2 plus 0, 3 plus 0, 4 plus 0, and we have a minus 2 plus 0, minus 3 plus 0, and minus 4 plus 0, right? I don't need to list these out, but the moment you observe 2, 3, 4 over here into 2, because they can also be negative, and then the entire thing into 2, because the same could be for m and n could be 0, right? So a total of 12 over here, right? 12 values where, let's write it as 12 values where one of them is 0, m or n equals 0, right? We're done with that. Now, what if m or n are is not going to be 0, right? If I put m as 1, right? What about n? N, if I put as 2, what's going to happen? We're getting 1 plus 2 is 3 and 1 plus 2 is 3. No, it's not working out. Go for 3 over here. And what are we getting? 1 plus 3 again is 4. No. So ones are not going to work out. What about a minus 1, right? A minus 1 over here. And minus 1 plus 2, let us say. And what are we getting? 1 minus 2 is going to be minus 1. So it's a plus 1. And over here as well, it's a plus 1. It's not working out, right? You could go in for some trial and errors this way. And then you'll see that, ones are not possible. What about twos? Zeros and ones we're done with. What about minimum value of 2? 2 and 2. And you have a 2 and 2 over here. It's 1 plus 4. And that's 5. And that's not possible, right? And that's it. I think at that point you can stop because there's no point going to 3 and 2, right? Because 3 plus 2 over here is not going to be less than 5, right? It's equal to 5. So therefore, at that point you can stop and you can go in for 12 values over here. And this is if you're going to be manually looking at it, right? If you have a lot of time in the exam and nothing else strikes for you, then you can look to manually do it. But see if something can strike, right? And what is the first thing which should? Model is over here, right? Is going to be positive, right? Model is over here is also positive, right? What you can always do, what is the other thing which is going to be positive? If I'm going to square it, right? If I'm going to square both sides, that's also going to be positive only, right? So therefore, the inequality will remain if I'm going to be squaring both sides, right? Once again, this output is positive, this output is positive. If I'm going to square both of them, 1 plus mn, the input might have been negative. But when I'm squaring also, it's going to be positive only. The inequality will remain. So what is 1 plus mn the whole square? I'll write that down over here. 1 plus m square n square plus 2 times mn, right? 2ab is less than m square plus n square plus 2mn. And then see where it goes, right? These two get cancelled. And if I move these to the side, m square n square minus m square minus n square plus 1, right? Is less than 0. Now, if I take an m square common, right, I'm going to be getting an n square minus 1. And if I take a minus 1 common, it's again n square minus 1. And that's it. M square minus 1 to n square minus 1 has to be negative. I know m square and n square are going to be positive for sure. They're both going to be positive. How do I ensure that one of them is negative, right? So just think about this. The only way you can get a negative out of any of them is going to be if you're putting a 0, right? If you put a 1, it's going to become 0. You don't want that. You need to be less than 0. If you put a 2, it's going to become positive, right? Only way to create a negative number out of one of them is going to be if you put a 0, right? So here we get a negative. Now, what about the other one? How do I ensure that that is positive? I don't want it to be 0. I don't want it to be 1 either, right? Because that will make it 0. 1 square minus 1 is 0. I need it to be 2 or more, right? What are the values allowed? I can take 0 plus 2, 0 plus 3, 0 plus 4, right? So it can be 2, 3, 4. It can also be minus 2, minus 3, and minus 4, right? and the other way around over here, which are m over here can be -2, -3, -4 with n being 0, and m can also be 2, 3, 4. So 6 plus 6, total of 12 sets of values over here, and that's what we got in the last time as well, right? This would be a more elegant way of solving, right? Provided this strikes during the exam. Okay, moving to the next question over here. So on to question 5. If 3x plus 2 times modulus of y plus y equals 7 and x plus modulus of x plus 3y equals 1, then x plus 2y is what, right? Now this is a question where we have, as I said, right, so linear equations types. Inequality is coming with respect to the modulus and how we're going to open it up, right? A quick look at the modulus once again. Modulus of x equals x if x is going to be greater than equal to 0 and equals minus x if x is less than 0, right? That's the modulus function. That's how it works, right? So how do we do it over here? A quick look again, 3x over here, and if x is positive, we get we're going to get 2x, right? 3x and 2x are not going to get cancelled. Now, what if y is going to be positive? Then we're going to get 3y over here, and we have 3y over here, and 3y gets cancelled, right? So that's one way to do it. The other is if we say x is going to be negative, right? If x is going to be negative, then x and this opens as minus x, right? Which will just get us 3y equals 1, y equals 1 by 3. And then we can conclude as to whether x is going to be positive or negative, right? That's another way of doing it. So whichever approach you can take, right? So let's start with the first one, which is, let's say y is going to be greater than equal to 0. If that is the case, then we know that, this is going to be 2y itself, right? It's going to open as y itself. So we're going to be getting 3x plus 2y plus y, which is 3y, equals 7. And the other one is going to be x plus modulus of x plus 3y equals 1, right? We can just subtract top minus bottom. 3x minus x, which is 2x, minus of modulus of x. This gets cancelled, equals 7 minus 1, which is 6. Now, modulus of x over here, it can open in two ways. So if x is going to be less than 0, let us say, right? Then what do we know? It's going to open as 2x minus of x itself equals 6, right? 2x is going to be plus x, right? So minus of minus x. Once again, just rewrite this. If x is going to be less than 0, it's going to be 2x minus of modulus of x becomes minus x, as we have seen over here, right? And equals 6. So 2x plus x is 6, so 3x is 6 and x is 2. Now, that is not possible when x is less than 0, right? Can't be positive. What about the other way around? If x is going to be greater than or equal to 0, right? Then it just opens up as modulus of x itself. We get 2x minus x equals 6, so x equals 6. This seems fine. However, I have to substitute into the first one and see as to whether y is going to be positive as well. So 3x, so 3 times 6 is 18 plus 3y equals 7. So y equals minus 11 by 3, right? So this over here is clearly not true, because if y is going to be greater than equal to 0, then how can it be negative over here, right? So we have a problem. So therefore, we now try it with the other condition, right? The other scenario. Now we know for sure that y is definitely going to be less than 0, right? We know that because it has to be the other way around. Both scenarios are ruled. I mean, this scenario is completely ruled out, right? Y can't be greater than equal to 0. So if y is less than 0, I know it's going to open up as a negative, all right? So 3x minus 2y plus y is going to be minus y equals 7. And over here, what are we going to get? So let's start off very quickly with if x is going to be less than 0, all right? What is happening? It's negative. Then we're getting x minus x plus 3y equals 1. And we're getting y equals 1 by 3. Now, y can't be positive. We have confirmed that, y is going to be negative. So therefore, this is rejected. This is not possible. X cannot be less than 0. I know for sure X has to be greater than 0 as well at that point. So if X is greater than 0, or greater than equal to 0, then it's going to open up as X plus X, which is 2X plus 3Y equals 1. Just multiply this with 3 and just add it up. 3 3s are 9 plus 2, which is 11x, and minus 3y and plus 3y get cancelled. 21 plus 1 is 22, and we get x equals 2. Now, if x is 2, what's y going to be? Just plug into the second one over here. All right, what are we getting over here? The second equation. 2 2s are 4 plus 3y equals 1. Y equals minus 3 by 3, which comes to minus 1. That's it. What is x plus 2y going to be? X plus 2y equals 2, and plus 2 into minus 1, which is minus 2, and we get 0. Option 1 over here becomes the answer. All right. So again, time consuming, yeah, compared to other questions, right? We don't know whether x or y is going to be positive or negative. Can't think of a better approach for this particular question, right? Graph and all of that might still be a little complicated for us to come up with. So therefore, look for easier questions, right? When you have something like this and you start off, you can just pause midway, go to something else and come back. Or if you're in a flow, you can just complete this pretty quickly as well, right? So moving to the next concept over here, right? So the next concept, and that is going to be around one of the most common things which turns up, which is quadratic inequalities, and where we use a number line over here to solve it, right? So first, let's look at the concept, right? So let's say we have something like x square minus 5x plus 6. Simple one is greater than 0 or less than 0. Doesn't matter, right? So factorize this. We get x minus 2 into x minus 3 is going to be greater than 0 as well. As long as the coefficients of x are positive, and which is the case over here, then what we can do is understand the roots. X minus 2 equals 0 means x is 2, and if x minus 3 is 0, x is 3. And the rightmost region over here, we have two cuts, we have total of 3 regions. Rightmost region is positive, next is negative, then positive. It keeps alternating, right? So just refer to the concept videos to understand as to why it works this way of the lesson, right? I'm not going to be getting into that in the revision stage of it. Now, positive, negative, and positive. What is the desired region over here? It has to be greater than 0. So this is the desired region over here, right? So now very quickly, what if it's going to be negative 4 minus 3x into x minus 6 into x plus 2 is going to be less than 0 or greater than 0 or whatever it's going to be, right? Can I draw the number line immediately? Do it? I can, but as I said, we need to make sure that the coefficients are positive. Here it's negative. The rest are fine. So once we have to multiply with a 1 minus sign, right? The moment I multiply with a minus sign over here, this becomes 3x minus 4. Just 1 minus sign that takes care of this, and the rest remain the same. But as I multiply only once with a minus sign, the inequality is going to change to greater than 0. Now, what if this would have been a 6 minus x instead, right? Then if that would have been a 6 minus x, then what am I doing over here? The first one I'm multiplying with a minus sign. The second one also with another minus sign. A minus into minus is a positive. So positive means nothing is changing over here. It remains less than 0, right? So remember that each of these individually I have to multiply with a minus 1. So 2 minus 1s make it a positive, right? So it continues this way. The moment you write it this way, you're able to express it this way. Draw the number line. What are the roots over here? The minus 1 first, right? That's minus 2. If x plus 2 is 0, then x is minus 2. Then here I get a 6. Here I get a 4 by 3. So 4 by 3 and 6. The rightmost is always positive, then negative, then positive and negative. I need the less than zeros. So these are the desired regions. That is minus infinity to minus 2, union of 4 by 3 to 6, right? So this is how we write it. This is the range which is acceptable for x, right? So couple of other things, right? Let me just touch upon those before I move to the examples which have turned up. Something like this hasn't come in the recent years, but you should be knowing, right? So let us say we have something like x minus 1 into x minus 7 into x minus 13 and goes on to x minus 91 is less than 0, right? Where x is an integer, right? This is true. How many solutions exist, right? Sorry for the handwriting, but yeah, how many solutions exist over here? Or how many integer solutions? How many different integer values can x take, right? So those can be your questions. So how do we solve for this, right? So first up, we need to understand as to how many cuts are going to be there, how many roots are going to be there, right? So if I want to draw a number line, and I can start with a 1 here, and then a 7, then a 13, and it goes on. And if I'm going to be ending it with a 91, which before that, what's the pattern? I keep adding 6 and I move to the next term. This would have been an 85, this would have been a 70, 9, and so on, right? Just put some dots. Okay, so how many terms are there, right? Arithmetic progression, AP, last term minus first term divided by common difference plus 1, right? That's the formula to find the number of terms. And 90 by 6 is 15, 15 plus 1 is 16. So there are 16 cuts. If I made 16 cuts, right, think about this. If I make 2 cuts, there are 1, 2, and 3 regions. So if I just have 1 cut, there are 2 regions, n extra region, n plus 1 regions. With 16 cuts, I'm going to get 17 regions. 17 regions. So if I start with a plus, then it's a minus, then it's a plus, and continues. If I start with a plus, I'm going to end with a plus because there are odd number of regions, right? 17 regions. So minus and plus and so on. So what are the desired values? I want it to be negative. So I want all the negative regions. Total of 17 regions, of which how many are positive, how many are negative, right? Positive and negative. Positive is going to be one extra. So I'm going to be splitting it as 9 and 8. How do I do it quickly? 17 by 2 is 8.5. One is 0.5 more, or the other is 0.5 less. That's it. 9 and 8, and that's the difference. So 8 regions over here, and those I'm interested in. And how many solutions exist? Between 85 to 91, how many satisfy? Between 1 to 7, how many satisfy? 2, 3, 4, 5, and 6. Right? 1 and 7 not included, less than strictly. Right? So therefore, 8 into 5, 40 solutions exist, or 40 integers satisfy. Likewise, 85, 91, 86, 87, 88, 89, 90. These two are not allowed. Right? So 40 is the answer for this question. But what if this question is going to be turned with a one simple less than equal to symbol over here instead of less than? That means it can also be equal to 0. When do they become 0? They become 0 at these points exactly, 1, 7, 13, and so on. How many such cuts are there? How many such points are there? We have 16 cuts, 16 roots types, right? So this 40 is where it's going to be negative. I have to add the 16 where it can become 0. The total becomes 56, right? 56 solutions becomes the answer for this question if it's less than equal to 0, right? So having said that, in fact, before I move to the next concept, just one last thing. What if you're going to have something like x minus 2 the whole square into x minus 3 the whole square is less than 0, right? For instance, the answer is it can never be less than 0, because a whole square, the lowest it can be, the least it can be is 0 or positive, can never be negative, right? So what if it's less than equal to 0? Then I can say it can be equal to 0 at x equals 2, x equals 3. That's it. Just 2 points would satisfy, nothing else, right? So the moment we have an even power over here, you need to understand that it's going to come out as a non-negative integer. So therefore, if you're going to have something like x minus 2 whole square into x minus 3 is less than 0, what's the range? You don't need to put a 2. That's wrong, because that part is going to be, that has an even power, right? We are concerned only about the odd powers. Here it's 1, x minus 3, right? So write down 3. Anything to the right of it is going to be positive. Anything to the left is going to be negative, and that's it. The only exception where it's not going to be negative is going to be at this point 2, where it becomes 0, right? The output becomes 0 because x minus 2 whole square is there. Anything other than it, right? 2.0001 or 1.999, all of that is going to result in a negative value, right? That's it. So remember this, even parts, keep it aside. You're concerned only about the odd parts in this number line, and that is what you have to work with. And you need to understand that, but those even powers, those roots, there it can become 0, right? That's the only condition over there. Okay, so let's now move to the questions, right? So question 6 over here. For how many integers n will the inequality n minus 5 into n minus 10 minus 3 into n minus 2 is less than equal to 0 be satisfied? Okay. Is it quadratic? Yeah, it is, because if we multiply with an n square, then minus 3 into something. Just write it in a simplified format, right? So n minus 5 into n minus 10 is nothing but n square minus 15n plus 50 minus 3 into n is minus 3n. Minus 3 into minus 2 is going to be a plus 6, right? Plus 6 is less than equal to 0. And what do we get here? We get n square minus 18n and then a plus 56 is less than equal to 0. 18, how do I split into two parts? Product is 56, 14 and 4, right? 7 and 8 is not, right? That's 15 only. So 14 and 4. N minus 4 into n minus 14, right? Quadratic simplification. I just refer to that lesson in case you're not familiar with this. N minus 4 into n minus 14 is going to be less than equal to 0. It's less than equal to. That's important. So on my number line, I have a 4, I have a 14, right? This is positive, this is negative, this is positive, right? Rightmost is positive. I'm concerned about the negative values and less than or equal to. So 4 and 14 should also be included, right? I want this also to be included. How many integers are there from 4 to 14? Both included. Y minus x plus 1. I've seen this in the numbers lesson, right? So counting consecutive integers, last term minus first term plus a 1. And we're going to be getting 10 plus 1, which is 11, right? So 11 becomes the answer for this question. Okay, let's move to the next question over here. And yeah, this is from one of the tougher years, right? So 2018 slot 2. And what do we have here? If a and b are integers, fine, such that 2x squared minus ax plus 2 is greater than 0. And x squared minus bx plus 8 is greater than equal to 0 for all real numbers x. So any x, if I'm going to put into this first one, it's always going to be greater than 0. It never becomes 0. It's never negative either, which means my curve is going to be something like this. And if my curve is something like this, what is my discriminant going to be? My discriminant is going to be less than 0, right? No roots over here. What about the next one? The next one is, it's going to be greater than or equal to 0, but never becomes negative. It could be equal to 0, could be equal to 0. So my discriminant in this case could be less than 0, right? What if it's always greater than? Or it could be equal to, right? Just about touches it. Because this expression over here is never becoming negative, right? So that's it, right? So we have two of these. It's around the discriminant actually. They're not speaking about real roots or distinct roots or imaginary roots or any of it, right? They are just placing it this way. This inequality is nothing but it's a quadratic question, right? Given that we've done the quadratic equations revision, let's look at this. How do we solve this? Discriminant is less than 0 over here. So for this, the discriminant over here is going to be a square. That is, b square minus 4ac, right? So minus a the whole square is a square minus 4 into 2 into 2, that's minus 16, is going to be less than 0 for sure, right? So how do we simplify? A square is going to be less than 16. The moment you apply a square root, you need to understand plus 4 and minus 4 are possible. And if it's going to be a square is less than 16, then turn it, moment you have the less than sign, it becomes easy. You can express a single inequality, minus 4 to plus 4, right? A square is less than 16. You know that if you apply square root, it becomes plus or minus 4. This inequality is going to change with the less than over here, right? If a is less than, a is going to be greater than -4 or less than 4, right? That's the range, right? If this is a little confusing, I mean, just get used to it, right? That's the more important part. But you could have proceeded over here itself, right? Which is if a square is -16, you could have written as a plus 4 into a minus 4 is less than 0, and then have a number line, and then have -4 and +4 less than 0, and this is what you want. And that's the same as this. A is going to be between -4 and 4, right? Why do I want this? Because this is positive, this is negative, and this is positive. I want it to be less than 0. Less than 0 is over here, right? Be flexible between the two of these. And yeah, so let's look at the next discriminant and the conditions over there. X square minus bx plus 8, discriminant is less than or equal to 0. B square, okay, minus b whole square is b square, minus 4 into 8 into 1 minus 32 is less than or equal to 0. B square is less than or equal to 32, and as we did over there, root minus root 32 is less than or equal to b is less than or equal to root 32, right? Now, what is this root 32? It's going to be a 5 point something, right? It's between root 25 and root 36. So it's going to be between 5 and 6, the output. Between 5 and 6 is 5 point something. Put some value, 5.6 and minus 5.6, right? Just to make your life a little easy. Now, what do I need to do? I need to find the largest possible value of 2a minus 6b. 2a minus 6b has to be maximized. If I have to maximize it, the positive term, I have to put as big a value as possible, minus of something, right? If I'm subtracting, I have to reduce as small a value as possible, right? What is the largest value a can take? A can take 3. It can't be 4, it can be 3. So 2 into 3 minus 6 into what can b take, right? B take. What is the lowest value b can take? B can't take minus 5.6. It has to be an integer. It can take minus 5, right? So we get a 6. Minus into minus is a plus. 6 into 5 is 30. And we get 36, right? 36 is the answer for this question. Heavy into concepts, right? A lot of scope to make silly mistakes as well. But remember this, right? So you have something like, this function is always greater than 0 for all real numbers x. Any input, it's going to be greater than 0. The curve is going to be looking this way. Discriminant is what should come to your mind. Okay. Let's move to the next question over here. Right. So question 8, the smallest integer n such that n cube minus 11n square plus 32n minus 28 is greater than 0, right? It's a cubic expression over here. How do we factorize it, right? So first up, see if we substitute 1. What's going to happen? We're going to get a 1 minus 11 plus 32 minus 28, right? I'm just trying to find some, a trial and error roots over here. So 1 minus 11 plus 32 minus 28 over here. This is 4 and no, doesn't work out. It's not equal to 0. Try a 2. 2 cube is 8 minus 2 square into 11 is 44 plus 32 into 2 is 64 minus 28, right? 64 minus 44 is plus 20. Minus 28 plus 8 is a minus 20 and equals 0. Yeah, it works. So 2 is one of the roots, right? So 2 is for sure one of the roots. Now, if 2 would have worked out, I would have tried -1, -2, and I would have skipped the question and gone to something else, right? So 2 is definitely one of the roots. How do I find the, what do you say? How do I divide it, right? We can use synthetic division over here. Write the coefficients down. 1 minus 11 plus 32 minus 28. And what do we get here? 2. First up, we have to put 0 and keep adding. 1 plus 0 is 1. 2 into 1 is 2. Minus 9, if you add it up, multiply with 2, you get a minus 18. Add it up, you get a plus 14. Multiply, you get a plus 28. Add it up and you get a 0, right? That's the remainder, perfectly divides. So this term over here can be written as n minus 2 into what? Into whatever you get over here. This is n square, n, this is the constant. Right? These are the coefficients. N square minus 9n plus 14 is greater than 0. Now minus 9n and plus 14, minus 7 and minus 2, right? It opens that way. N minus 2 into n minus 7 into n minus 2 is greater than 0. So n minus 2 the whole square into n minus 7 is greater than 0. Now, what did I tell you about even powers? Ignore, doesn't matter. Just 7 on the number line, and that's it. Right is positive, then negative over here. At 2, it becomes 0. But I'm not bothered about it becoming 0. No greater than equal to, strictly greater than. So at 7, it becomes 0 as well. I don't want that. What is the smallest integer n where this happens? The first integer after 7 over here, which is going to be 8. At 8, it's going to definitely become positive, right? It's on the positive side. So that's the answer for this question, right? So let's move to the next one, right? The next question. And what do we have here? F of x equals x squared plus 2x minus 15 divided by x squared minus 7x minus 18 is negative if and only if they want it to be less than 0, right? Less than 0. That's it. And we have some ranges given over here. Looks like number line. We have to plot it. So just factorize the numerator and denominator separately, right? That's the way you have to do. X squared plus 2x minus 15. If you're quick with this, you'd be able to get x split it as 5 and minus 3, right? X plus 5 into x minus 3, right? And the denominator, I want a minus 18, so minus 9 and a plus 2, right? X minus 9 into a x plus 2 is less than 0. Now with inequalities, it can also be division, right? Need not be only in the numerator, it can also be in the denominator. You can't throw it to the other side because we don't know whether it's positive or negative. You can't keep it as it is. Just get a number line in. Moment the right hand side is 0 and less than, bring in the number line. And also make sure that the coefficients are positive, which it is, right? Which is good. Now, what's the leftmost? I want the negatives, minus 5, minus 2. Okay. And then the rights 3 and 9, right? Those are the positive roots. And I want less than 0, right? So I have positive, negative, and positive. I want only the negatives. Minus 5 to minus 2 and 3 to minus 9. I mean 3 to 9, right? This is just minus 9. Right, so minus 5 to minus 2 and 3 to 9 is there in option 4, right? So option 4 over here becomes the answer. Okay, moving to the next question over here. For all real values of x, the range of the function f of x equals x squared plus 2x plus 4 divided by 2x squared plus 4x plus 9. But here what we are asked to find is the range, right? 3 by 7s, the 4 by 9 and a lot of 3 by 7s and half, 8 by 9 and all of that, right? How do we, and if you look at 1 and 4, the values are the same, it's just the bracket, right? And what does this bracket mean over here? Let's say 4 to 5, right? It simply means x over here is going to be greater than or equal to 4, but less than 5, right? A parenthesis over here or a curved bracket over here, common bracket, means that value is not included, but less than that. A square bracket over here means that including 4 over here, right? So that's the only difference between 1 and 4, right? So how do we do this? What's going to be the answer? Now, for us to find the range, right, I would want to work with one quadratic expression, not two, right? Can I get rid of the top one in any way, right? How do I get rid of the top one? X square, and here I have 2x square. The ratio of coefficients is 1 by 2. Ratio of coefficients over here for x term is also 1 by 2. So if I multiply the numerator with the 2, I'm getting 2x squared plus 4x plus 8. 2x squared plus 4x over here. It can get cancelled, right? Let's see as to how to do that. So f of x over here equals, I'm going to divide by 2 and multiply with 2 at the same time. If I'm multiplying the numerator with 2, I'm going to be getting 2x squared plus 4x plus 8 divided by 2x squared plus 4x plus 9, right? Now, I want it to become, I mean, the coefficients have been brought to that. The constant is away. It's different. How do I bring the constant to the same? Just add a 1, then it becomes 9. But I can't just do add a 1. I have to subtract a 1 then to bring it back to 0. Now this part over here is now going to be the same as this. 2x squared plus 4x plus 9. That can get cancelled. And we get half into 1, right? If I divide, minus of 1 divided by 2x squared plus 4x plus 9, right? That's it. Now, what's going to be the range of this function for the function itself, right? The output. Now, if 2x squared plus 4x plus 9, if x is going to be a huge positive number, very big positive number going close to infinity, right? What's going to happen over here? First off, we know that, this is going to be, this curve is going to be like this, right? It's going to be, because the coefficient of x square over here is positive. It's U-shaped. It goes up to infinity, right? For a huge positive number, I know for sure all of them are pluses. It's a huge number. It's close to infinity. 1 by infinity, right? If denominator is close to infinity, this tends to 0. Then half into 1 becomes half. But can it touch half? No. However big a value you might have, 1 divided by that is still going to be a very small amount, right? Very small number. It's not going to touch half. So it's something like this, right? That's the upper limit, half, the highest value it can take. When is it the highest value? If 2x squared plus 4x plus 9 is very big, this entire term becomes very small. If I'm subtracting a very small number, I'm getting the largest value, right? Half into 1 minus a very small number. That's the largest value it can take. What about the smallest value? Smallest value over here. Now 2x squared plus 4x plus 9, what is the least value it can be, right? What can it take? And so if you know the formula, it's 4ac minus b squared by 4a, right? We can directly do that. 4ac, 4 into 2, 8, 8 nines are 72, minus b square, which is 16, divided by 4a, 4 twos are 8. 72 minus 16, 72 by 8 is 9, 9 minus 2 over here is 7. I can do it that way. Or you can apply x equals minus b by 2a, that's where it becomes minimum, minus b by 2a, and we get minus 1. Plug in an x equals minus 1, you get 2 minus 4 plus 9, which is 11 minus 4, and that becomes a plus 7 as well, right? Either ways, we're going to get the same. So 7 over here, it can take, right? So if it's going to take a value of 7, then we're going to get half into 1 minus 1 by 7, right? Sorry about that. Half into 1 minus 1 by 7. That's the lowest value over here. So half into 1 minus 1 by 7 is going to be 6 by 7. You simplify and you're going to get 3 by 7. So it's going to be from 3 by 7 to half. Now, can it take the value 3 by 7? Yes, it can, right? This can be 7. So this has to be included over here. So 3 by 7 to half this way. So option 1 over here becomes the answer, right? So more of a, looks a little tricky. It's a question of, observing that the coefficients of x square and x, right? The ratio is the same. So multiply and divide by that whatever value you need to get rid of the quadratic expression in the numerator, keep it at only one place. Then I can find the range, right, with these. Okay. Let's move to the next question. Question 11. Let a, b, c be non-zero real numbers such that b square is less than 4ac. Okay. B square is less than 4ac, b square minus 4ac. Bring it to one side is less than 0. If that is the case, discriminant is less than 0. Then what do I know? Then I know my curve over here is going to be like this, right? It's not going to be touching the x-axis, but the curve can also be like this, right? Can be in the bottom, not touching the x-axis at all. Fine. F of x is ax squared plus bx plus c. Now, it's going to be like this when a is greater than 0, like this when a is less than 0. We don't know which, we don't have a. A is just a non-zero real number. Can be negative or positive. Fine. If the set S consists of all integers m such that f of m is less than 0, then set S must necessarily be set S consists of all integers m such that f of m is less than 0. If f of m has to be less than 0 over here, all the real numbers, then all real numbers itself, right? All real over here, if this is the curve. Now, what if this is the curve? F of m is less than 0, it's not going to be at all there, right? So a set of all integers is possible. Empty set is also possible, right? If it's going to be this way. So the answer over here is either the empty set or the set of all integers. Set of all positive, no. right? So real number, non-zero real number, it can be anything. So either the empty set or the set of all integers. So option 2 over here is the correct answer, right? So quite a few quadratic inequalities questions, right? So which is turned up. Same with linear inequalities as well, right? So now let's move to the next concept over here, which is the modulus, right? So the modulus function, briefly defined that earlier, which is modulus of x equals x if x is greater than equal to 0 and minus x if x is going to be less than 0, right? So how is this going to look, all right? Modulus of x is going to be like this. That's modulus of x. What if it's going to be minus of modulus of x? This is how it's going to be, minus of modulus of x. Now, the slope of x is 1, so it's just going to be this way, right? 45-degree angle. So if I make it 2x, it's going to become a little steep, right? And so on. Now, what if it's going to be a modulus of x minus 2, right? The slope is 1. Where does it become 0? It becomes 0 at 2. From here, I'm going to draw something like this, right? Get a sense of the graph as well. Now, what if it's going to be 5 minus of modulus of x minus 2? Now, modulus of x minus 2 is this. Minus of that is going to be inverted, right? It's going to be like this. But I'm adding a 5 to it. If I add 5 to every such value, it's going to all go up by 5 units. And we're going to get something like this, right? At x equals 2, that's where it's going to attain maximum. 5 minus of a 0, right? We get the highest value of 5, right? 5 over there. This is how it's going to look. Just refer to the lesson, practice this a bit, all right? Make use of the site called desmos.com, desmos.com. It's a graph plotter. You can just put in some of these, quadratic or rational functions or anything, right? So modulus and all of that, and observe the graph as to how it looks, right? So the deflection point over here matters, makes a lot of difference. Now let's look at one other concept before we move on to some questions, right? Modulus, where it's going to be something like x minus 3, can be looked at as a distance on a number line, right? What do I mean by that? If I say x minus modulus of x minus 3 equals 6, it simply means where does it become 0? The point 3, right? So from that point 3, the distance of x minus 3 means simply the difference between these two numbers. That is, the distance between these two numbers on the number line has to be 6. 6 units to the right is going to give me 9. And 6 units to the left is going to give me 3 minus 6, which is minus 3. These are the two values for x, right? Another way to look at it. Rather than opening it as what if x minus 3 is greater than 0, then it opens this way and find the value of x. And what if it's less than 0 and find the value of x? Instead, you can go in for something like this, right? What is that once again? It's going to be the distance from 3, right? Distance from 3 is going to be 6. That's it. Now the question will be, what if it's going to be a positive x plus something, x plus 5 equals 2, right? Then you can rewrite this as x minus of minus 5. Always I need a minus sign over there. And the moment I have that, put a minus 5. It simply means 2 units to the right or 2 units to the left, right? What is that? That's going to be a minus 7 or a minus 3. Try it out. Those are the two values. Minus 7 plus 5 modulus is going to give me a 2. Minus 3 plus 5 modulus is also going to give me a 2. Those are the two values which satisfy. You can also look at it as a distance on a number line, right? Now, distance on a number line can also apply with inequalities and where it's going to be linear. If modulus of x minus 3 is going to be less than 6, right? Then what does that mean? I have a 3 over here. From there, 6 units to the right is 9. 6 units to the left over here is minus 3. I want the distance from, distance from 3 to be less than 6. Max, it can go to 6. No, it can't touch 6. It has to be less than that. So the range acceptable over here is minus 3, 9. Any point you find over here, which is greater than minus 3 or less than 9, the distance from 3 is going to be less than 6. Take anything to the left of this 8. What is the distance of 8 to the 8 from 3? That's 5 units. 8 minus 3 is 5 units, satisfies. Take something like minus 2. What is the distance over here? The distance over here is 5 units. Put a minus 2 here, minus 2 minus 3 is minus 5. Put a modulus and you get 5 units. So it's all going to satisfy, right? So this is the range we look at. Let's look at a few examples now, a few questions which have turned up in CAT, where we can use this to solve, right? First one, the number of integers n that satisfy the inequalities modulus of n minus 60 less than modulus of n minus 100 is less than modulus of n minus 20, right? Two inequalities over here. Take one at a time, right? Take one at a time. Let's take the first ones. So modulus of n minus 60 is less than modulus of n minus 100, right? What does that mean? On a number line, let's put a 60. Let's put a 100, right? This over here is distance away from 100 and this is distance away from 60. Now, what it essentially means is I need to find the values of n where its distance from 60 is less than the distance from 100, right? So 60 and 100, these scenarios, put the midpoint over here, which is 80. I want it to be closer to 60 than to 100. Therefore, this is the region. To the left of this, anything to the left is closer to 60 than to 100. Anything to the left is closer to 60 than to 100, right? If you look at the right side, that's going to be closer to 100 than to 60. So the distance to 100 is going to become smaller than the distance to 60. I don't want that. Distance to 100 should be more than it, right? So this is the region I want. All those which are less than 80 satisfies. Take the next set over here, which is this one. Modulus of n minus 100 is less than modulus of n minus 20. What does this mean over here? Let's draw a number line. Put a 20, right? That's the first one. Then 100. What's the midpoint over here? 100 plus 20 by 2, which is 60. Now the distance to 100, distance from 100 should be lower than distance from 20. It should be closer to 100. So I want this region, right? So this one says n has to be less than 80. This one says n over here has to be greater than 60. If you just want to put it in the same line, you can just say over here, and I want this region. So n has to be between 60 and 80. Can it be 80 or 60? No, less than equal to is not there. It has to be less than. So all values between 60 and 80, not including 60 and 80, is 80 minus 60 minus 1. Y minus x minus 1, excluding both. So 20 minus 1, 19 becomes the answer. Option 4 it is over here, right? Let's move to the next question. And the same here, different slot. For a real number x, the condition modulus of 3x minus 20 plus modulus of 3x minus 40 equals 20 necessarily holds if, okay, what are they saying? The distance from, 20, but I have 3 over here, right? On a number line, it's easy if I don't have this 3. I don't want a 3 over there. How do I get rid of the 3? Positive number. So I can divide both left-hand side and the right-hand side with the 3, right? And what do we get? Modulus of 3x minus 20 by 3 is 3x by 3 minus 20 by 3. 3x by 3 is x minus 20 by 3. I can rewrite it now. Plus x minus 40 by 3, right? Equals 20 by 3. What does it mean? The distance from 20 by 3 plus the distance from 40 by 3 should be 20 by 3. Okay, let me put a 20 by 3. Let me put a 40 by 3. I have to find points such that the sum of the two distances is going to be 20 by 3. Now, if I find any point between the two, let's say I find this point, what is going to be the sum of the distances from 20 by 3 and 40 by 3? That's nothing but the total distance over here between the two. What is 40 by 3 minus 20 by 3? That's 20 by 3. That's the distance. So any point you find between them, it's going to add up to, it's going to satisfy this equation over here, right? Straight up. So if you're going to have something like modulus of, for instance, x minus 5 plus modulus of x minus 7 equals to 2, then 5, 7, any point between them is going to satisfy. Equals to 1 never satisfies. Any point, minimum distance is 2. Minimum is 2. The moment you hit that 2, infinite points between 5 and 7. The moment I move to something like 4, I need 1 extra from each of them. Minimum is 2, so it's going to be 1 to the right and 1 to the left. This is the slightly tougher part. Not too much. If you know the minimum distance is 2 and I need 2 more, I divide the extra 2 by half and I move 1 to the right and 1 to the left from these. 4 and 8, if you try out over here, it's going to definitely satisfy, right? So you can try this later. This is a little more complex, doesn't turn up as often, right? We've seen these in the classes. Coming back to this, right? Coming back to what we have at hand, right? So I just gave you those integer values so that it's easy for you to understand. It's the same over here, 20 by 3 and 40 by 3. Difference is 20 by 3. Any point in between satisfies this. So what is 20 by 3? 6.67. 40 by 3 is 13. 1 by 3, 13.33. So it says for real number x, this holds if, which inequality? For which inequality? X is between, or which range of x? X is between 6 and 11. Between 6 and 11, no. 6 to 6.67, it doesn't satisfy. 9 to 14, 14 is stretching beyond this, not allowed. 10 to 15, 10, okay. 15 is too high. 7 to 12, 7 is to the right of 6.67, yes. 12 is less than this, perfectly fine, right? 7 to 12 is definitely within this range. And here it holds good. So option 4 becomes the answer for this question. Okay, let's move to the next one. Question 14. The largest real value of a for which the equation modulus of x plus a plus modulus of x minus 1 equals to has an infinite number of solutions for x, right? So infinite number of solutions. So what we had seen earlier, right? That's the concept. Now, if I find for x modulus of x minus 1, the deflection point is 1. And for modulus of x plus a, the deflection point is minus a. Minus a, if I put over here, right? Minus a I put over here. And the distances, the sum of the distances is 2. Infinite number has to be between them, right? Between them only, between the two of them. So between the two of them, that means the distance is 2. If this is 1, this becomes 3. If minus a is 3, then a becomes minus 3, and that's not there, right? That's not there. So instead of on the right hand side, what if I move this minus a to the left hand side? Minus a over here, such that the distance is going to be 2 again, right? Between 1 and minus a, the distance over here is 2. So 1 minus of 2 is going to give me a minus 1, right? If a over here, I mean minus a is minus 1, then what happens over here? All these points between minus 1 and 1, if you're going to plug in as x values, it's going to satisfy. The sum of distances is going to be 2, right? So if minus a is minus 1, then a is going to be 1. It's nothing but modulus of x plus 1 plus modulus of x minus 1 equals 2. Just a quick look again. Minus 1 to 1. Any point in between. 1.5, right? Sorry, 0.5. 0.5 is 0.5 away from here and 1.5 away from here. That just adds up to 2. Take a 0. 1 away and 1 away adds up to 2. All points between are going to satisfy as long as the distance between these is this 2. All right. Anything beyond that is going to be finite set of points. Only at this exact difference, it's going to be infinite. Right. So therefore, we just solve for it. Largest value a can take is plus 1 over here. Right. Minus a is minus 1. So a is going to be plus 1. So option 1 is the answer for this question. right? So seems complex, but if you practice these questions itself and you're very clear with the concepts over here, it's going to become quite easy, right? On to the next question. Let 0 less than equal to a is less than equal to x is less than equal to 100, okay? And f of x is modulus of x minus a plus modulus of x minus 100 plus modulus of x minus, okay, this part, x minus of a plus 50, right? Let's combine that, okay? Then the maximum value of f of x becomes 100. So complex, right? So becomes 100 when a is equal to which one, right? And a over here is greater than or equal to 0. X has to be more than a. So we have 4 options over here. And we need to find out where the maximum value is going to become 100, right? The maximum of it. Just try out some of them, right? So if a is going to be equal to 0, if a is going to be equal to 0, then x minus a, right? So a over here, and then we have an a plus 50, and then we have 100, right? Modulus of x minus a, distance from a, modulus of x minus 100, distance from 100, modulus of x minus of a plus 50, distance from a plus 50, right? So if this is 0, then this becomes 50, right? When a is first option, we'll try it out. Then what is the maximum possible distance, right? Maximum value of this is the max possible 100 over here, right? X over here has to be greater than or equal to a. What if x is equal to a itself? Distance is 50. I mean, distance to a itself is 0. 50 plus 100 is 150. It's definitely exceeding 100. So 0 is not possible over here. 0 is not possible. What about the next one? 25. Let's try it out. The a is 25. 25 plus 50 is 75. X has to be greater than or equal to a. Try from here itself. What are we getting? Right? 25. Sorry, 50. 50 over here. And then a 75. 50 plus 75 is going to be 125, right? If x is going to be 25 in this scenario, 25 minus 25 is 0. 25 minus 25 minus 50, that becomes a plus 50, and 25 minus 100 is a plus 75, right? The modulus. 75 plus 50 is 125. That's, it doesn't matter whether this is the max, but there is a value which is greater than 100, right? So that rules this out. So 0 and 25 are ruled out, right? So quickly. And let's draw this line again. 50 and 100 I have to try out. We could go with 100, right? Quickly. That's a big value for A. And distance from 100 and again distance from 100, right? There are 2 points over here. If A becomes 100 and this becomes x minus 150, right? This becomes x minus 100 minus 50. If x has to be between 100 and 100, right? If A is 100, x can take only one value, which is 100. And distances from 100 itself for x is going to be 0. Distance from 150 is 50. The maximum distance, only one distance of 50 possible value. It can't be 100. 100 is also ruled out. By elimination, you can go for option 350 itself, right? But let's try it out. Let's see as to how 50 is working out. If A is going to be 50, this is modulus of x minus 50 plus modulus of x minus 100 plus modulus of x minus 50 minus 50. Once again, x minus 100, right? So there are 200s over here from where I have to find the distance, and I have a 50 over here. Now, any point over here, I have to add twice the distance, here is only once. And x over here has to be greater than 50 and less than 100. So as I move to the left, I can be adding it twice, right? The longest distance twice. And that's what I want. If x is going to be sitting at 50, modulus of x minus 50 is 0, but that to 100 is going to be 50 plus a 50, the distance. And that comes to the maximum possible value or output of 100. That's where it becomes 100, right? So this is definitely a lot more difficult question, right? If it strikes and it's there, you're able to eliminate and go quick, then yes. If you're very sound with this concept, then yes, go for that. If not as much, look for easier questions first, get done with those and then come in for something like this. Yeah. Let's move to the regular normal way of solving, right? Nested in multiple modulus. A couple of examples over here, right? We'll work with those. How many integer values of x satisfy modulus of x? And then we have another modulus inside is less than 3. Now, quick thing over here. If modulus of x is going to be less than 4, we can quickly open it as if it's less than, right? Minus 4 to 4. Right? Remember that. If you can remove this modulus directly, it's going to be working out this way. If it's going to be modulus of x is greater than 4, then you have to say x is greater than 4 or x is going to be less than minus 4, right? Two ways. But if this is going to be a less than symbol, like this over here, life becomes easy. How do I get rid of the first modulus over here? When I do that, I'm going to have a less than 3 and less than minus 3, as I said, right? 3 over here, minus 3 to 3, it becomes, right? Input, if it is minus 3 to 3, modulus is going to make it positive and is going to make it less than 3, right? Logically look at it. Now I have a minus 1. Now when I have multiple inequality symbols, I have to start doing arithmetic operations on each side of it. I want to get rid of the minus 1, so I will add a 1 everywhere, right? All regions. Minus 3 plus 1 is minus 2, and minus 1 plus 1 is cancelled. Modulus of x minus 1 is less than 4. A modulus is always going to be greater than minus 2, so it doesn't matter, right? This part is redundant because a modulus is going to be 0 or more. So if this would have been a plus value, a positive value, then it makes sense to continue that way. Here it doesn't. Ignore it. Modulus of x minus 1 is less than 4. Now I can again open up the modulus as between minus 4 and 4. Again minus 1, add a 1, and what do we get? Right? What are we getting over here? Minus 4 plus 1, which comes to minus 3, and this is x is less than 5, right? 5 over here. Minus 3 to 5, how many integer values can x take? Not including, right? So 5 minus of minus 3 minus 1, because both these values should be excluded. And that's 5 plus 3, 8. 8 minus 1, and that comes to 7 over here. So 7 becomes the answer for this question, right? On to the next question around multiple modulus, right? Multiple modulus this time around. Where 2x is an integer, how many values of x satisfy modulus of 3x plus 4 is less than equal to modulus of x minus 2? Okay, this is a lesson example. How do we go around solving this? Now, these questions where we have two different modulus, right? And you have a 3 as a coefficient here, 1 over here. Just go in for plotting the points. Deflection points or roots over here is going to be x is 2. Here is minus 4 by 3. So minus 4 by 3 and 2. Now here, both the modulus are going to be positive. Here, one of them becomes negative. Which one? Where the deflection is 2. That becomes negative over here and remains negative. The other one was positive over here. And at minus, when it goes below minus 4 by 3, this also becomes negative, right? And this is for modulus of x minus 2. Now, where both are opening as positive, then 3x plus 4 is less than equal to x minus 2. Bring the x here. 2x is less than equal to minus 6. X is less than equal to minus 3. Can it be less than equal to minus 3 and greater than 2 at the same time, this region? No, right? Number line tells me that it should be positive and not just positive, more than 2. Can it be less than equal to minus 3? This is rejected because of that. If this is true, x should be less than minus 3, not possible, less than equal to. Next over here, 3x plus 4 remains 3x plus 4, right? 3x plus 4 less than equal to modulus of x minus 2 is going to become 2 minus x. Multiply with minus 1. Bring the x here, becomes a 4x is less than equal to, take the 4 there, it becomes a minus 2. X over here is less than equal to minus 2 by 4. 4 comes as a positive term, inequality doesn't change. Minus 2 by 4 or minus half. Fine. Minus half over here. All right. And this region is fine. All right. Not the right. On to the last part over here. Both are negative. So 3x plus 4 is going to become minus 3x minus 4 is less than equal to 2 minus x or minus x plus 2. Bring the x over here. You get a minus 2x is less than equal to, take the minus 4 there. It's a plus 4, 6. So x over here is greater than equal to. Why? Because when I take the minus 2, sign is going to change. X is going to be greater than equal to 6 by minus 2, which is minus 3. So what do I want? I want it to be greater than equal to minus 3. So I want it to be over here, and it has to be less than minus half, right? So this is the acceptable range. The question asked over here is 2x is an integer. If 2x is an integer, then what is acceptable? X can be something by 2. How many values over here are something by 2, right? Something by 2. It simply means x can be a half multiple. Half multiple is a 0.5 multiple. What are my 0.5 multiples over here? Both inclusive. Minus 0.5, minus 1, minus 1.5, minus 2, minus 2.5, and minus 3. How many values are there? 1, 2, 3, 4, 5, 6. 6 values over here, right? Minus, it has to be a 0.5 multiple. If you want a direct formula, 0.5 is the common difference, minus 0.5, minus of minus 3, both inclusive, right? So divide by the common difference, plus 1. So this over here is going to give us a minus 0.5 plus 3, which is a 2.5. 2.5 by 0.5 is 5 plus 1, which comes to 6. And 6 is the answer for this question, right? So seems a little complex, right? Made it a little complex towards the end. With 2x being an integer, you could be asked that in the exam as well, right? So be ready for that. 2x is an integer, x is a half multiple. If 3x is an integer, x is a 1/3 multiple. So remember those. Okay. So now on to a question where it's a minimum of a multiple modulus. We look at straight with an example from question over here, the 2003 paper, right? So what do we have here? Your multiple modulus adds up to a certain function. It simply means the distances from what? Now, modulus of 2.5 minus x, right? Very important. Please note that. Within a modulus, right? Within a square, 5 minus x the whole square equals x minus 5 the whole square. Doesn't make a difference. Plus or minus gets taken care of. So modulus of 2.5 minus x over here, or like 5 minus x equals modulus of x minus 5. Within that, you can multiply with minus 1. Same you can do here and write it as modulus of x minus of 2.5 plus modulus of x minus 3.6. What are my points over here? 2, 2.5, 3.6. Distance from 2, distance from 2.5, distance from 3.6. Find those, add them up. When is it the least? If there are only 2 points, 2 and 3.6, then anything between them is fine. But if there are 3 points, it has to be exactly on top of it. If it's sitting on top of it, the distance from 2 and 3.6, we know that's a constant. But if it's sitting on top of it on 2.5, then distance from 2.5 is 0. We're getting a 0 plus this. Anything away, if we pick something over here, then we are getting distance from 3.6 and 2. Yes, that's the same constant as this. But here there is a distance from 2.5 created over here, right? It's created. A value of 3, for instance, would be 0.5 more than this. So exactly on top of this, the middle value over here in questions like these, that's going to be the answer. You can just mark it and keep going if you understand the distance part of it. Yeah. So that's the concept around minimum, right, with multiple modulus. Moving to the next part of it, the last part of this lesson over here, right? So here we deal with max and min, right? When sum or product are going to be constant, right? So this is the part which is taught in terms of, or rather proven in terms of, AM is going to be greater than equal to GM, right? That is what is going to be used, right? But instead of expressing that way every time, let's look at it this way, right? So if the sum is constant, A plus B equals 12, the product over here gets maximized when A equals B equals, in this case, 6, right? 6 into 6 is 36. AB over here gets minimized when they're far apart from each other, right? So A equals 11 and B equals 1 if both are positive integers, right? 1 into 11 is just 11, right? So that way. Where sum is constant, the product gets maximized when they are equal. Where product is constant, let's say 36, then sum of A plus B equals 12, right? Gets minimized when they are equal, right? A equals B equals 6. It's the other way around, right? So remember this. You can quickly write it down this way as well. Or if you know the AMGM part of it, that's fine as well, right? Let's move on to the examples over here and look to solve them. If three sides of a rectangular park have a total length of 400 feet, okay, which means A plus A plus B equals 400. Okay, 2A plus B is 400. Then the area of the park is maximum when the length of its longer side is what? That means AB over here has to be maximized. Sum of two terms is constant. Then the product of the two. Product is what? 2AB becomes maximum when 2A equals B. But I want AB to be maximum. When 2AB is maximized, 2 is just a constant. Then AB also gets maximized. 2 times something has to be maximized, then something has to be maximized, right? So therefore, this is all fitting the bill. That's it, right? So 2A plus B is 400. The product gets maximized, AB gets maximized, right? And when is the product getting maximized? When 2A equals B. If 2A equals B and sum of these two is 400, you have to equally split it as 200 and 200. 2A equals B equals 200, right? Only then 200 plus 200 is 400. So if 2A is 200, A equals 100. If B is 200, B is 200. The question asked is, when the length of its longer side is how much? Longer side over here is 200. And that becomes the answer for this question. Yeah. Okay. Let's move to another question. The number of distinct real roots, right? Number of distinct real roots of the equation x plus 1 by x the whole square minus 3 times x plus 1 by x plus 2 equals 0. Right, something like this. We can just replace the inside term over here with y. If y is x plus 1 by x, then we get y square minus 3y plus 2 equals 0. Quickly, we can factorize y minus 1 into y minus 2 equals 0. So y over here can be 1 or 2. Now y over here can be 1 or 2. Now x plus 1 by x, right? Now why is this coming under this? Sum over here, right? Sum of two terms. I have to see what values it can take. But what is the product of these two? The product is a constant, which is 1. When the product is constant, the sum becomes minimized when they are equal. So sum becomes minimized when x equals 1 by x, which means x square equals 1, x equals plus 1, right? If they're going to be both positive. And we have 1 or 2 over here, right? 1 or 2. So x equals 1 is what is going to minimize this value, right? Minimize the value. And what is the minimum possible value we're going to get over here? 1 plus 1 by 1, which is 2. 2 is achievable. That's the minimum possible value. And that's at x equals 1. Now, can this be equal to 1? Can never be 1. The lowest possible positive value is 2. It can't be lower than 2 and be positive. It can be negative, right? If we're looking at real and all of that, can be negative, right? Which simply means if plus 1 is the minimum possible value, if you enter the negative world, right? A root of 1 could be negative 1 as well. Minus 1 becomes the highest possible value in the negative side, right? For x, this is the range, right? Has to be greater than 1 or less than minus 1. Or if you plug in the values over here as minus 1, we're getting, what is the output over here? It's 2 and minus 2. It can be more than 2 or less than minus 2. It cannot be y cannot be 1 over here. X plus 1 by x cannot be 1. So 1 is rejected, 2 is accepted. So therefore, number of distinct real roots is exactly 1, right? Only 1, and that is when x is 1. Next question. What do we have here? For real x, the maximum possible value of x divided by root of 1 plus x power 4. Now, maximum or minimum, typically when asked with quadratic, either we use the quadratic inequalities over here, all right? Or we can use quadratic function, we can express it as and try to do it. And if you're not able to do that, the other thing we should strike for you is inequalities, right? Where sum of product is maximum. Now I have an x here, I have a 1 plus x power 4 with the square root, right? Divide both of them by x, numerator and denominator. So this is going to be equal to x by x divided by root of 1 plus x power 4 by x. X by x is 1. And if I bring this x inside the root, I'm going to get 1 plus x power 4 divided by x square. And this now can be written as 1 by x square plus x power 4 by x square, which is just x square. Now the product over here is constant. When product of the terms 1 by x square and x square, right? If I multiply these two, it becomes a constant. The sum, what happens? The sum gets minimized, right? The sum gets minimized when they are equal. If the sum has to be, if the denominator gets minimized, the value, right? The entire value gets maximized, and that's what I want to find. The maximum possible value of this. Maximum possible value is when the denominator gets minimized. The sum over here gets minimized when they are equal. That is 1 by x square equals x square, which means x square equals x power 4 equals 1. X equals, x square is going to be plus 1 for sure. It can't be minus 1, right? That's it. If x square is going to be 1, 1 plus 1, right? What are we getting over here? 1 by root of 1 plus 1, which is 1 by root 2. 1 by root 2 over here is the maximum possible value of this function over here, right? So that's question number 21. Moving to the next question. What do we have here? Slightly different type. We saw that negative also, no? Something around that is over here. If C equals 16x by y plus 49y by x for some non-zero real numbers x and y, then C cannot take the value of what, right? Some of this cannot be what, right? For which again, if I multiply these two, x gets cancelled, y gets cancelled, I'm getting a constant. 16x by y into 49y by x is what? If they get cancelled, I'm getting a constant which is 16 into 49, right? Which is nothing but 4 into 7 the whole square. 4 into 7 the whole square. Which again means each of these, right? The sum over here gets minimized if it's positive, right? When it's going to be, each of them is going to be 4 into 7 and 4 into 7. I have to equally distribute, right? 28 and 28. That's what it means. So if it's 28 and 28, C equals 28 plus 28 is the minimum positive value, 56. But it can be negative as well, right? Some non-zero real numbers x and y, they can be negative as well. So on the negative front, it's minus 28 and minus 28. That's it, right? If I apply the square root over here, it can be plus or minus 28. So minus 28 minus 28 can be minus 56, right? On a number line, accepts all values to the right of 56, all values to the left of minus 56. Anything in between is not allowed. Minus 70 is here, it's fine. Minus 50 is to the right of this, that's not fine. Minus 60 is to the left, it's fine. 60 over here is to the right of 56, that's fine. Minus 50 over here is what it cannot take, right? CANNOT. Option 2 over here is the answer for this question, right? So once again, a quick look. If the product is going to be constant, and what is that constant? 16 into 49. If the product of two terms is going to be constant, you can just rewrite this as C equals A plus B, where AB The product of these two is a 16 into 49, which is 4 into 7 the whole square, or 28 square. If product is constant, split it into two equal parts. A and B have to be equal, means A is 28, B is 28, but they can also be negative. That is minus 28 and minus 28. So on this number line, if this A and B are 28 and 28, it's coming to 56. Minus 28 minus 28 is minus 56. It can be away from 56 or away from minus 56 on the negative side. Those two are acceptable regions. In between is not possible. This is the minimum possible positive value. This is the highest possible negative value, right? The same mirror image is what is created over there, right? Simple concept. Remember that questions like these are coming up quite often, right, in the exams. Now let's look at another one with max and min, right? When there is a sum or product, right? Okay, so what do we have here? X, Y, and Z are positive integers. X plus Y plus Z is 20. So the maximum value of this is what? I have to maximize this, right? So maximum value of a product is when they are equated, when the sum is constant. Is the sum of these terms constant? What is the sum of these terms? X plus 3 plus Y minus 1 plus Z plus 2 equals what? Equals X plus Y plus Z. 3 minus 1 is 2. 2 plus 2 is going to be 4. Okay. But what is X plus Y plus Z? That is a constant. That's 20 plus 4 and comes to 24. Sum of these terms is 24. Then the product gets maximized when they are equal. So 24 has to be equally distributed to each of them. And I will distribute it as 8 and 8 and 8. 8 into 8 into 8. 512 is the answer. You don't need to do X plus 3 is 8, so X is 5, and then substitute 5 here and get 5 plus 3 is 8 and waste time over here. The moment you know that each of these should be equal, and find that equal value and plug in and multiply them, and that's the answer for this question. Yeah. So now we shall move to the last concept under inequalities. That's where we get this, area enclosed in the graph type questions. And in these, these questions could also be considered to be coordinate, right? And come under that. Let's look at them, right? So let's look at them. The area of the closed region bounded by the equation mod x plus mod y equals 2, right? So common type over here. If both are positive, then x plus y is 2. Both are negative, minus x minus y is 2. If x is positive, y is negative, then x minus y is 2, and so on. So remember this. We're going to be getting, if x highest possible value over here is 2, when y is 0, right? What about the lowest possible value for x? It's at minus 2. When x is 0, y can be plus 2 or minus 2. We are just asked to find the area bound by this. It's a square, right? It's a square over here. All right. So what's the side of a square? This is 2 and this is 2 from 0, right? So this is 2 root 2. What's the area of the square? A square, 2 root 2 the whole square, and that comes to 8. Okay, option 3, 8 is the answer over here. You can also call this a rhombus, right? A square is also a rhombus. So this diagonal over here, 2 to minus 2, that's 4 units. This is also 4 units. Half d1, d2 is the area of a rhombus formula. So half into 4 into 4, that will also get us 8, right? 8 becomes the answer over here. Badly drawn, just to give you an idea, it's going to be like something like this. Yeah, slightly better than the other one. But yeah, you're going to be getting a square over here. 2 minus 2, 2 and minus 2. Yeah, so if this is 2 and 2 units, Pythagoras theorem, this is going to be 2 root 2, right? Yeah, isosceles right angle triangle. Okay. Moving to the next one, right? But do remember mod x plus mod y over here, and you get a square, right? Forward by 2 years, and what do you get? And you get another question, something very similar. Mod x plus mod y once again, right? So these are common types which turn up, right? So remember them. Mod x plus mod y is less than equal to 2. So get them to equal to 2. Equal to 2 is going to be this way. I'm just trying to draw my best over here. Okay. 2 minus 2, 2 and minus 2. And I want it to be less than equal to 2. So anything inside, that's what it means. Anything inside it is satisfying it. Anything out, take some point inside, 0, 0, satisfies. Take something outside over here, doesn't, right? Take a 3 and a 3 or something. No, it doesn't. So therefore, we know that it's anything inside over here which satisfies. Mod x is greater than equal to 1. Mod x greater than equal to 1 means x is greater than equal to 1. Or x can be less than equal to minus 1. Right? Remember that with mod x. So you just need to draw something like this. And I want this. And something like this over here. And I want this. That's it. Right? So how do I find the area of the shaded region over here? For the entire thing, we know it's going to be 8. We just saw earlier, right? 2 and 2. This is 2 root 2. Area of the square. Area of square equals 2 root 2 the whole square. That's 4 into 2, 8. But I don't want these parts. Okay, if that is going to be 8, this region over here is going to be what? This triangle over here is going to be half of the entire thing. That's going to be 4. So let's take this triangle and straighten it this way, right? Or rotate it a bit. And I want only the top triangle, right? And what do I know about this? This base over here is at 0. And this is at 2. And this is going to be at 1, right? Which means the height over here is 1. The height for the entire triangle is going to be 2. And what is the area of the entire triangle? That's going to be half of this square, right? 8 by 2, 4 units, 4 square units. Back to this, if you remember similarity, then you'll know that half, the ratio of the heights over here is what? 1 is to 1 unit divided by 2 units for the entire triangle. The shaded triangle is 1 unit, 2 to 1. The entire triangle is 2 to 0, 2 units, 1 is to 2. Then what is going to be the ratio of the areas of the two triangles, right? Whole square, right? 1 by 4. So 1 is to 4 is the area of the two triangles. If the entire triangle's area, which we saw was 4 units, then the smaller triangle's area alone is going to be 1 square units. So this shaded region is 1 square units, and this one is also 1. 1 plus 1, it's a total of 2 square units over here, right? So that's the area of the shaded region over here, right? And which is what we need to find. So practicing again, some of these is going to get us to it, right? Let's move to the next one. The area of the region satisfying the inequalities, mod x minus y is less than equal to 1. Y is greater than equal to 0 and y is less than equal to 1. So y has to be between 0 and 1, right? So that we need to remember here. Y has to be between 0 and 1. Now, how is this curve over here going to look? Let's write it as in terms of y. Take the y to this side. It's going to be y less than equal to mod x minus 1, right? Mod x minus 1. Or switch it, y is less than equal to mod x minus 1. Okay, so now I can do this. Mod x I know is going to be like this, but I have to subtract a 1. So it's going to be pulled down by 1. Pulled down by 1 unit, but at a 45-degree angle. So this is going to be 1. This is going to be minus 1. Just try it out. You put a 1 here, you're getting an output of 0. Correct. Put a minus 1, you're getting an output of 0. Right? It's cutting the cutting the x-axis. Now, y over here has to be less than equal to mod x minus 1. Take a value, anything in between this, 0, 0. Does it satisfy? 0 is less than equal to minus 1 over here. So y over here, I mean, y should be, in fact, the other way around, right? That's a mistake I made over here, right? So if I take y over here, it's greater than equal to mod x minus 1, which is correct. But when I put the y in this side and mod x minus 1 over here, it's the other way around, all right? It's the other way around. Should be greater than equal to. The inequality has to be changed, right? I've changed the sides. That's it. Silly mistake over there. But yeah, what made me realize that I tried a 0, 0 and looks like, it should be the outside range. That doesn't make sense. Now try this value 0, 0. 0 is greater than minus 1. Makes sense. So therefore, this is the acceptable range, right? So this entire region over here is acceptable. Do I need to find for the entire thing? No, there's one more range given over here. Y is between 0 and 1. So y equals 0 is nothing but the x-axis, and y equals 1 over here is going to be parallel to the x-axis over here. We need to find the area of this trapezium over here, trapezium, right? So where it's going to be 1, where y is going to be 1, what is this x going to be, right? X going to be, if y is going to be 1, this has to be 2 minus 1, right? So x could be 2 plus 2, right? This was 1 and this was minus 1. So x is going to be 2, and here it's going to be, can be minus 2. Minus 2. That's it. What is minus 2 to 2? That's a total of, let's draw this trapezium over here. Minus 2 to 2 is going to be 4 units. Minus 1 to 1 is a total of 2 units. What is the height over here? 0 to 1. That's 1 unit, right? Height over here is 1 unit. What is the area of this trapezium? Half height into b1 plus b2. Half into 1 into 4 plus 2. That's 6. 6 by 2 comes to 3, right? So 3 over here is the answer for this question.